Checking to see if my stream is working real quick before I continue. The goal for today is to update some of my AI for my enemies. For now, as you can see in the game video here, we just have idle. It'll sit idle for a certain amount of time and then it'll move. And then it'll sit idle and then it'll move. So I need to make it so that when the player is close to an enemy, within a certain distance, the enemy will start to rush the player. And I need to make sure that they don't step on top of the player as well. Then from there, we're going to add some attack mechanics. The attack mechanics are going to be the enemy will highlight a tile on the ground, and the player will have to dodge that tile. We have different enemy types. So we have a sword, shield goblin here, a mage goblin, just a standard goblin, melee goblin. We also have a bow goblin. Should be able to show you here. Yeah, right here. So we got a ranger, we have a melee, we have a defender, we have a major. I think I said major twice. 4 or 5 different enemy types. Yeah, because we have the basics. So 5 different enemy types. And that means we're going to create the basic AI for now, and then we're going to inherit from those basic enemy AI traits. In order to create there we go, we are live. Alright, so we're gonna have to inherit from different enemy traits, and we'll have like an inheritance kind of a tree. So we'll have the main basic AI. That main basic AI is going to apply to every single enemy in the game, and then depending on if they're a ranger, if they're a major, if they're a melee, etc., they'll have different abilities. And this will apply to different enemy types as well. I'll show you the overworld real quick. If you look down here, this is the orc encampment. This is where we're going to enter the orc area. We have dwarves. They're going to have different logic from the orcs. Metal knights. It's kind of hard to tell, but this is a ghost. A little graveyard level. A mage level. A monster level. And we have rat here, a rat level. I also have a water level. It's going to have water enemies, krakens, etc. So, as far as development goes, the goals today. I'm going to write it down somewhere. Where can I write it down? Oh, was my VS game even showing? Should have been. I'm gonna assume it was. Okay, so as far as where we could write this down, we could just do a notepad for now. Or maybe we could do like Excalibur. That would be an interesting Excalibur. I would of course have to learn how to use Excalibur. Okay, scout drop. I'll crop that a little bit. Okay, we have our Excalibur. We have the enemy AI here. Enemy AI is gonna have certain, that's inheritance. Gonna have certain traits. Boom. Okay. Alright, here's our basics for the enemy. Idle, walk, run, attack. Throw those in the corners so we can throw a little detail in there too. Come on, bro. Works for the others. Okay. Walk. We need number of steps. For run, we need to know if is player close. The big one. And we also need to know the speed at which we're going to run. Now for attack, since we're just doing a basic attack, we're going to need to know the tile. Tile to attack. Okay, we need to know the tile to attack. What else? The speed of the attack. Okay. We also need to know where the player's current position is. Okay. Idle's a quick one. I'll just knock that out real quick. Idle duration. Walk. We're also going to need to know for walk direction. Okay, so the player steps close to the enemy. The enemy recognizes that the player is close. So we need to override its current state to chase the player. So we need some type of chase player function. Um, as far as preventing the enemy from stepping onto the player, is player close is more of an overarching enemy AI method variable. Let's type bool, so let's declare the type on that. Okay. So we need to, for run, we also need direction for run. Okay. So if player's close, true, then we're gonna have to run towards the player. Makes me wonder about logic. Logic to keep the enemy running towards the player when he leaves aggro range. Because the player could then just dip in and out of aggro range, and we don't want that. So I think chase player is going to have to include a duration that it will chase player. Let's also it's called duration to chase. Yeah, duration to chase. Maybe I'm thinking right now my logic to spawn the enemies is just random all over the place. Go ahead and load up the game real quick and show. Better. Okay. Let's type these real quick. Idle duration is an integer. No, it's a float. Because we're applying delta time to it, so it's a bool. Number of steps is an integer. Number of steps. Direction is also an integer. But I think in my current logic, yeah, direction's an integer between 0 and 3. Up, down, left, right. 4 directions. Make sure direction's an integer. Okay, run. The speed, we'll float that so we have some good variation, like 0.5s, etc. Direction is also an integer. Chase player. That's a void, type void. So the enemy AI is going to need to know the player's direction, so... I'm thinking we'll either need some type of update method for the enemy AI, so we consistently update the knowledge that it needs. Because I don't think we want to give enemy AI the player, right? We don't want to import player into enemy AI. Like, enemy AI doesn't own a player. It's an enemy AI. It owns enemies. So we need some type of way to update the player position for the enemies. Okay, I know how we can do that. Tile to attack. Do we vector that? Just theoretically, that would cause a lot of... It would require a lot of math. If we... The maps are 20 by 20, but you can update based off of what you want the tile size to be. So 20 by 20 would be 400, so a number from 1 to 400, then applied to the 2D array of the tile system. That just sounds way too complicated and unnecessary. So tile to attack is going to be a vector 2. Speed of the attack, that is going to be a float. Player position is a vector 2. So in my code I have a for loop going for enemy and enemies, and it's updating in-game.update. So from there I can update some information for the player's position. I can give it the player's position. Let me look at the actual code real quick. Let's go to game. Okay. Inside our game update, level manager. Oh, it's inside level manager. Update enemy state machines right here. This runs every frame. This method will run every single frame of the game. So inside of this update here, we can feed the player's position. Let's find where we're recording the player's position. Should also be an update. Game owns players, so yeah, right here. So theoretically, we can just pass the player from here. Update enemy state machines. Not level manager. Is it? It's okay. So yeah, from here we just feed in a player. It does make sense that level manager would own a player. Well, not own a player, but would have access to player. The level needs to know where the player is. So I think we're good there. Update enemy state machines, player, and then from here, update player. Just give it player. Okay, but why is it incompatible? Enemy state machine, update. Player, pointer, player. Player, pointer, player. It could be that we're currently running the game. And it's not. Here's what the issue is. Where should be in entities, right? Entities player.h doesn't know what a fucking player is. That was the issue. So theoretically we should run now. Now we got one more thing to fix. Does not take one argument. Here, player. Boom. There we go. We're good now. Okay, and then let's just do a little bit of printing to make sure that we're up, like, double check we're getting the actual. Yes, we are. Okay. You can't see it, but in my command prompt window, we are updating the player's position correctly. Okay, so that allows us to feed the player position into whatever AI that we want to do. So we're good there. Back to Excalibur. Okay, chase player. Chase player is a function of run. in our code also to allow for clamping. I don't fully like the logic we have for clamping yet. This is my current clamp logic here. We define next I, next j. If next I is greater than 0, and next I is less than or equal to the size of the map. So tile size is 8. So it's the sprite size is 8. So tile size therefore is also 8. So our 20 by 20 gets multiplied by 8 to find the current coordinates of wherever the enemy is. So if the enemy wants to leave the map on their next move, they can't, because it's because it doesn't allow, because this if loop never enters, where it changes the enemy's position. So I don't like the current setup for the clamp logic, because if I want the enemy to run, that'll allow them to leave the map. If the player's out of the map, which theoretically won't be a legal move, but if I want to, in the future, clamp them to a certain area, then I need to move the clamp logic to its own method, and then call the clamp method. But I can't figure out how to successfully do that right now. That's a problem I'm currently facing and I have to solve. So theoretically, I could just it would just be this line of code right here, and then we give it the next I and next j, and then our run logic is exactly the same as walk. However, our speed, we change we add like a speed variable. So let's try that. Just throw in a quick clamp. Private void clamp integer next I and next j. Oh, the max. We gotta get the max x and max y in there as well. We have to feed the enemy into? Yeah, we do, apparently. I guess this does make sense due to our current system of how things are done. Which, whoa, I misspelled clamp terribly wrong. Right? Okay. So our current system is enemy AI, right? Enemy AI is fed into an enemy state manager. So, give me 1 second. Close all. I've got like 30 different tabs. No. Alright, so we have our enemy state machine right here, which takes in enemy AI. So, state machine, I believe, is a pointer inside of game. Enemy state machine, where are you at? Oh, it's inside level manager. Boom, boom. Level manager, where you at? Generator. Yes, enemy state machine is a pointer because how we generate a battle. We randomly walk around, we generate a battle, boom, our world is generated. I call it world, but I've got world and I've got dungeon, and I have the ability to, like, say we have like a mountain, you know, a mountain level, etc. It's basically just a world, brings up world tiles. I'll show you in the game. Okay, we're in the overworld. The overworld is a 20 by 20 pre-generated level. Now, say we're walking around and we come into a random encounter. We generated the random encounter inside the overworld, so we want there to be trees, grass, etc. So, this is a world level. We get back to the overworld and just say we're in the dwarf level that's not made yet, and the whole world's going to be like, this is the main area. It's going to branch off into different areas. So player touches tile here, generates dungeon level, leaves, it goes to black. Touches tile here, generates the orc level, leaves, returns to black. Okay. We're now in the dwarf level, we're in a dungeon. And then we run into a random encounter that's in a dungeon. We don't want trees to be inside of a dungeon, so it's a dungeon world, or dungeon level. That's what I mean by world level and dungeon level. The idea is for later in the future when we're in like lava levels, we got lava level, you know, right? Modularity in the future. The systems now that I create are with the future in mind, so that it's easier on me and I have to only do like minimal editing for to get the next segment or level inside of the game. So what was I talking about to begin with? Enemy state machine. Okay, so we start a level, boom, the level generates, enemy state machine pointer appears, and then that enemy state machine has enemy AI. So this allows us to have different types of enemy AI. Currently, this is what our big project is, combat enemy AI. In the future, we're going to change this enemy AI, just single enemy AI, into a array of enemy AIs. So we have our, if you look on the level, we've got this mage. Yeah, you can see my mouse on here. We have a tank. We have a mage. We have just a generic. We have a bow wielder. And I don't think we have a sword wielder, right? So we have an array of enemy AI that is fed into the enemy state machine. The enemy state machine has access to all of the outside stuff that the enemy's AI needs to know. This includes player position, where they are in the world, etc. And it gives the enemy AI what they need to know to do their job. So this is created also with modularity in mind, because I'm not putting enemy AI that I'm building today into the level manager. If I did that in the future, I'll have to search through my level manager code, which is more than just enemy AI, to try and figure out how to update the code. Instead, we're an enemy state machine that drives all the enemy AIs. So in the future, if I need to update the enemy AI, I go to enemy AI. If I need to update the enemy state machine, I go to enemy state machine. And I'm only looking at state machine code. I'm not looking at world generation, etc. And I think that answers the question that I just brought up. So, okay. Back to the code. We're creating a clamp. We've got it. So here, we can comment that out, and then we should be able to just clamp enemy, our current enemy, next I, next J, max X, max Y. Boom. So this should theoretically clamp. Now, I'm gonna edit these values real quick. Currently hard-coded values. Just because I want to do a little test. That's just driving the speed of how often they move around. So they should move around a lot quicker now. Just making sure that they don't, they still don't, like the logic stays the same, and that they don't want to leave the map. And it looks like we're good. Nice. So we have clamp logic we can also apply to run. Okay. Delete that. Clamp enemies. Nah, we could just leave it the clamp. It's an industry term, kind of a jargon thing, so. I mean, if someone else looks at this code and sees clamp, what the fuck does clamp do? I'm kind of worried about that, but is what it is. I think we're good. I think that's like a minimal detail that really that we could just run a little comment for so they can read it. Prevents enemies from leaving. Generated map. Cool. Perfect. Okay. Oops. Delete that. Okay. Idle, walk, clamp. Clamp method, and that method is type void. Forgot to show you Excalibur. There. Okay. So run. Speed the speed at which they update. That is our, if you can potentially, no, I don't think you can. Currently, that's just getting a random value. So when we have idle time, and enemy. This is a system I have to think more through. Enemy right now owns its idle time, and I don't know fully if I want them to own idle time. Whereas I think enemy AI would be better. But how do I'm trying to think out, how do I apply idle time from the enemy AI class, enemy AI object, to an array of enemies? That's why I originally did this design choice, is because I can't figure out logically how to apply an individual idle time so that the enemies aren't all updating at the same time, you know? I think this is a problem we can solve when we are a bit more designed out for enemy AI. Yeah. Okay. Is player close? Oh, you know what? I should actually update my stream title. All right. So I think logically the next step is to build out the running. I think our plan's pretty good here. We don't need a delta time variable because we're feeding delta time. Okay. Let's start implementing. You know what? That actually might be a state machine if the player's close. I need to turn this to a pointer as well. Do I? Yeah, absolutely. Now, does not belong on enemy AI. I'm gonna be right back. We're back. Minus, I need to do some sort of abs value here. Updated consistently, and we're feeding player pointer into player position. Yes. Yeah, we already checked that it's updating consistently. So if enemy I I don't use the C++ math library often, so I need to check documentation on this. I know it's ABF for absolute value. Absolute value of an integer. Okay. Standard abs. Whoops. Now I have something similar to this in some other code that I wrote. I can't fully remember where. But I know I can go off of that if I wanted to. Integer enemy player distance. Player distance equals, not minus equals, J with player Y. Player distance X, whoops, X, player distance Y. Dist X, dist Y, dist X, dist Y, okay. Dist X, dist Y. Then also, for now, my level manager, I believe, want to only create one enemy. Which reminds me I need to update some of this code. This is hard-coded for now. Is it in my level generator code where I decide how many enemies? Generate monster spawns, here it is. Level monster count right here. So So we want 1. Do we do like this distance? 24? To start running towards the enemy? Or enemy start running towards player? Maybe like 32 I feel like would be good. Is less than or equal, greater than or equal to, less than or equal to 32, or player distance y is less than or equal to 32. State. Enemy state equals state run. Okay. State dead definitely needs to take precedence over everything, so that we're not creating dead enemies that can move. Should be an else if. Okay, so if the enemy's alive. Sorry, if the enemy's not alive. State dead. Else. If the enemy, if the player distance and enemy distance are less than 4 tiles, less than or equal to 4 tiles apart, then we want the enemy to run. And then, okay. So that does cause one issue though, I think. And we can actually test this real quick. Okay. So we're no longer entering state walk, correct? Okay. And we're also still printing off the player distance, so we do not stay inside of the states. We do run the code block before state. So that was just like a logic question I had about states, about switch cases. Okay. Good to know. Okay. Now, we're gonna break the logic here real quick. Just let's double check our Caladraw diagram. Run needs speed, a float, direction, an integer, and a chase player method. Let's help me see that a little better. Okay. Run. Okay. Player enters distance range 4 tiles. Enemy. Oh, we need to flag a boolean. How do we do that? Drop the Excalibur. Okay. We need to change this boolean from enemy AI. You know what? Enemy AI is... I think it should be part of enemy AI is player close. I think it should be. Because then, inside of our... No. Damn. The AI should know if the player's close, yeah. It should not be a state machine thing. It just makes sense logically. State machine should only handle generating the state. State machine should only handle moving between each state, but the enemy AI has the actual logic of the state. So knowing if the player's close is not changing a state. Okay. It can actually be... It can be... the variable can be for... the enemy itself can know if the player's close. So then that allows us inside the state machine, enemy is player close equals true. Okay. Ooh, man. We need to... I think we need a nested if here. Okay, so if the enemy's not alive, state is dead. Otherwise, we're gonna run other code. That'll prevent... Yes. Logically, that makes more sense. So if the enemy's dead, they're dead. Otherwise, if the distance, and then we can run like an else if. Run greater than. For now, I'm going to comment that out. And then this way we don't have to hard code so many. Return a put back to state idle, and enemies no longer close. Okay, so that's going to prevent as soon as the player gets in range. Prevent the enemy from permanent aggression. Okay. That doesn't solve the problem of continuing to chase the player when they're outside of aggression range. So that's not a problem to solve right now, I don't think. So as far as run logic, enemy position, enemy I minus equals player. So we need to feed player in. No, we don't. We need to feed player distance X and player distance Y. And these are integers. They should never be floats. No, we don't feed distance. We do. That's gonna prevent us from being able to walk on. Okay. And then we need to, I guess, feed in... do we want to feed in the player? No, we don't need to. You can feed in player position. Vector 2. Okay. I should have a fucking notebook up here. I mean, I do. It's my Sonic the Hedgehog. Oh, there's green on there. My Sonic the Hedgehog notebook for game notes. Okay, grab a pen. I know I have a pen over here too. Maybe up here. There it is. Okay. This is like normal game logic that I should know. What I'm trying to figure out, okay, so if the player's above, then their position's going to be below. It's from top left down is the coordinate space. So in this case, the player's above. Yeah, you can see the player's above, the enemy's below. The player has a lower value than the enemy. So if the player's below, the enemy's above, how do I close this distance most effectively? That's my question. That's what I need to find out. I mean, I could... No, couldn't. Pretty sure every single project I've done before this is just minus equals, right? So it'll be minus equals 8. So the distance minus equals. But distance doesn't control. Might have to go to AI for this one. Let's resort to Google first. Yeah, this is... If I was using Unity, this is already done, or Godot. There's already a method to do this. I have to, like, make my own. Okay, step 1, define direction. Step 2 is to move direction. Step 3 is to allow time between movements. We don't need AI for this, we can do it. Okay, step 1, define direction. If player position, if player position dot x is less than enemy position, enemy I, direction, int direction. No, we don't need that. Next, I. Okay, so if players to the left, yeah, left, less than left. Next I minus equals 8. Let's create int next I. Not idle time, I. Next J is J. If player position dot x is less than enemy x. I kind of messed that up in the beginning. I and x are interchangeable. Because when I was making the grid movement, I was thinking like I and J. We'll just use I and J because it's a 2D array. I and J, so it'll make looping easier. But no, we should have just done X and Y to begin with, but it's okay. It'll be a hell of a refactor in the future, and we'll deal with it then. So, yeah, we're technically just copy pasting what's up above. Let's just do an else if player position dot x is greater than enemy I. Boom. Duplicate twice. Change our y and j y. Next I plus equals 8. Next y minus equals, so if player position is less than enemy, so we're gonna plus equals, because yeah. And let's also see if I can remember the keybind. Oops. Okay. Just so that we can. That's left. That's right. Boom. So that we can stay consistent with our walk logic. Just realized our clamp logic doesn't only prevent bounds, it also moves. Problem solved. We'll fix that later. Okay. So we type just boom, boom. Max X and Max Y. I'll feed that in too, I guess. Make sure let's hold off on the clamp. No, we do still need Max X, Max Y. So yeah, let's just do that now. We technically don't. Because what if we just... Just realized my game's running. You guys can't see any of the code I'm doing. Oops. There's gonna be a lot of cleaning up that needs to get done. Because the enemy AI should know the bounds of the map. The state machine should only worry about transitioning. So map width and map height. Width and map height. But we need to... No, we do not. That is not a value we need to update because the map does not change width and height through the runtime of the program. Well, after it's initialized. So when we create the enemy AI, what? Oh, because we're doing this one more level above inside level manager. Create the AI. Enemy state manager. That's going to be when we initialize the world. Here. Okay, so we trigger the the battle. We initialize the world. That deletes the null pointer. And then world enemy state manager instantiates a new enemy state manager with the enemies, the width and height. Boom. Enemies width and height. So from here, where do we create the AI? What? Hold on. Because the enemy AI has logic, right? It still has logic when we converted that to a pointer. Does it? Does it still move around? Ah, I see. We never... Okay, so just never noticed it. Alright. Do we keep it a null pointer? Or keep it a pointer? Yes, theoretically we do. Is there a constructor for an AI? Don't have one. We can't do it in an update. Maybe we don't pointer this. Can we pass by copy the AI? The AI never changes logic. We're never... Theoretically, there won't be any variables of the enemy AI to change. So, we technically do not need to make it a pointer. I don't even think we need to pass by reference either. Yeah, because if we're not changing anything about the enemy AI, there's no reason to make it a pointer or a reference. Right? But I'm also actually kind of confused why this was printing off earlier. Well, I guess because we're not actually even yeah, because that's part of it. Jeez. Makes sense. Okay, I just want to run a quick check real quick. Go ahead and move. So our state logic just must be broke. Here, when we were editing this, we probably broke something. State 2, enemy. State 2 is to run. Yeah, so we just broke some logic. If the enemy's alive, or if the enemy's not alive, they're dead. Else, if the player distance on the X is less than or equal to aggression range, or the Y is less than or equal to the aggression range, going to state run and flag the player's close. Otherwise, if it's greater than the aggression range, or if X is greater than aggression range, or Y is greater than aggression range, we're gonna enemy state idle. It has to do with this logic here. Still stuck on state 2. Right? And we stay idle, walk, run. So we're stuck on run. Let me double check. Gotcha. Okay. That's our mess up. There we go. There's just an and 7 or. And then we're idling around. Back to 2. Okay, we just need to reset after we... That's an extra wide diagonal. We'll worry about that later. We're still stuck on 2 though. Oh, or. Wait. Just an else. Gotta make sure we're not locking him out from movement in idle. We are. Okay. That's not correct. Okay, if this is fine, break that up. Otherwise, we just don't change states. Then we update the individual logic. Something like idle, walk, run, attack, die. Oh, I see. Still stuck on run. Be right back. We finished the goal for today. 2.5 hours too. And I did have to use AI. But only for this specific problem. This line of code was wrapped inside of a... Oh, can't see. This highlighted line of code right here was wrapped inside of a an if statement that only ran if the player wasn't within range. But we need to, like, our logic switches to idle between. So idle, our state system goes to idle, does what it wants to do, walk, run, goes back to idle, does what it wants to do. And so the speed mechanic of the enemy state system is the time spent in idle. And only allowing it to go into idle when the player wasn't close was causing an issue. So I'm super happy with how this turned out. We even did a little diagram too that I'm gonna have to save because I'm making a video about the combat. So Paul44 you are. Thank you, brother. Thank you. Welcome to the stream. I talk to myself a lot because I have no viewers, but yeah. Appreciate you stopping in. I'm about to end the stream though. I'm starving and I've got some real life responsibilities to take care of. However, what we got done for the day, we drew out the diagram. We already had delete. Okay, so we already had idle going. We already had walk. What we created was the run. And so we do have to change about a little bit of the logic for walk and idle. Specifically, we created the clamp and move method that we're going to split into a different clamp and a different move method. But we also created all of the run logic, which is very similar to the walk logic, except for rather than rolling a random direction 0 through 3, we had to figure out where's it at? Probably on a state machine. Yeah, this logic here minus the debug, grabbing the absolute value of the distance so that we could use this to prevent, show you in the code or in the game itself, when the enemy, I've got 2 game instances going. I didn't know I could do that in VS Code. Okay, so when the enemy's close, we don't want the enemy to walk on top of the player. So we use absolute value of distance. Oh, I gotta end early, sorry. Hope you all have a great day and take care. Hello?